Hi, how are you? I want to welcome you today for the chemistry tutorial in the topic, the most disturbing topic from the topic of molar concept and the related calculations. Yeah, so I want to show you the best and easiest tricks how to master the molar concept problems. Okay, wow, now you are welcome. Yes, let's go for the question number one. Yes. So determine the molar mass for the following compounds. So here we have the compound number one, sodium oxide. Number two is hydrated copper 2 sulfate. Okay, let us go. Now for the solution number 1A, this is sodium oxide. So you write here again, sodium oxide. What is the chemical formula for sodium oxide? The chemical formula is sodium Na and then O. The valence of 2, so here will be 2 and this is 1. So this is the chemical formula for sodium oxide. If you do a mistake and you write chemical formula in wrong way, it will be impossible for you to get the right molar mass for the particular compound. So it should be correct one. You should consider the balances of each ion. So here, sodium oxide. So I'm going to take it as here sodium. What is the mass of sodium? Sodium has mass of 23, relative atomic mass of sodium. It is 2. So here we times 2, times 2 plus the relative atomic mass of oxygen, which is 16. So this will be 23 times 2, which is 46 plus 16. Therefore, it will be, this one will be 62 gram per mole. The SI unit for molar mass is gram per mole. Let's go for B. Yeah, for B, it is hydrated copper 2 sulfate. How do you do it? What is the chemical formula for copper 2? Hydrated copper 2 sulfate. Copper 2 sulfate, this way, pentahydrate. Yes, copper 2 sulfate pentahydrate. So this is the hydrated copper 2 sulfate. So we go one by one. If you have the relative atomic mass of copper, copper is always 63.5, sulfur is 32, and oxygen is 16, hydrogen is 1, and the oxygen is 16. Okay, oxygen again is repeated. Okay, so now let's try calculate the total molar mass. Copper, this one is copper, so this is copper, 63.5 plus sulfur, which is 32, then plus oxygen. How many oxygen? The 16, how many? They are 4. So 16 times 4. This one plus here 5 times water. H2, hydrogen is 1 times 2, so it is 1 times 2, this one, and oxygen, which is 16, yes, this number. So collecting that one, it will be 249.5. Then the SI unit is gram per mole, or sometimes one can write it as copper 2, therefore copper 2 sulfate 5 pentahydrate equals to 249.5 gram per mole. Sometimes G per mole can be written in this way, in exponential form or in fraction form. Yeah, so that is. Now let us go for number 2. Zero 0.46 gram of sodium. Yes, what to do here, look at the data that were given. Here you have mass of sodium. and you are asked about moles. So you are given this is asked one, and you are given this one. Okay. So what to do here is from the formula that number of moles is given by mass over molar mass. So here, look, what is the mass given there? The mass given by this was 0.7, 0.46 gram. Divided by the molar mass. Molar mass of sodium is always 23. So it is 23 G per mole. That is the relative atomic, atomic mass of sodium. So dividing this one, you will find that number of mole is equal to 0.05 moles. So that is the answer. Let's go to question number 3. Let us proceed here. This is question number 3. How many moles are there in each of the following particulate entities? A, you are given 214 atoms. So you are asked about number of moles and you are given number of atoms. From the formula that number of mole is given by number of particulate entities or particulate particles, number of particles divided by the Avogadro's constant, Avogadro's number. That is the formula. And here you have whereby number of particles you are given this. So N is 214 atoms. Another data, Avogadro's constant is, this is the Avogadro's number is constant. That is always, it is 6.02 exponent 23 atoms per 1 mole. So 1 mole contains this. And I am required to find the number of moles. So number of moles will be given by this one, 214 atoms divided by 6.02 exponent 10 exponent 23. That is atoms per mole. So taking this, you will find that number of mole is equal to 3.55 exponent 10 negative 22. What? Moles. Yeah, so that is the answer. For B, let's go for B. B, you are given molecules. So what is that? You are given number of molecules. N equals capital letter N, 7.5 exponent 50 molecules. And Avogadro's constant is known. That is 6.02 exponent 23. What? Molecules per mole. Yeah, that is what? Avogadro's constant. And we are required to find the number of moles. How much is this? So we go, number of moles equals to number of particulate entities or number of particles divided by Avogadro's constant. So taking there N, which is 7.5 exponent negative exponent 50, yes, divide by Avogadro's constant 6.02 exponent 10 23 exponent 23, yes. So dividing this one, you will find that the number of particles is equal to 1.25 exponent 10 27 moles. Yeah, that is question number 3. Are we together, my friends? Wow. Let's go for question number 4. We are going deeper and deeper and deeper. Yes. Yes, question number 4. Calculate the number of particles in each of the following: A, 0.29 mole of iron, and B, 19 mole of copper 2 sulfate. Yes. Solution here. Look at the data given. For A, you are given that number of moles, that is number of moles, small letter n, equals to 0.29. This is mole. And then you are required to find the number of particles. This one, capital letter N, number of particles is equal to how much? But always remember that the Avogadro's constant is always given. That is La is equal to 6.02 exponent 23 particles per mole. My friend, note that when we say particles, these particles include atoms, molecules, ions. Okay? Yes, atoms, molecules, ions, or electrons sometimes. Yeah, so any terms can be used there. So now, from the formula, number of mole equals to number of particulate entities divided by Avogadro's constant. But I'm required to find this. So make capital letter N the subject, which will be N equals to NLA. Yeah. So this one, we take it as N, small letter N, that is 0.29 mole times Avogadro's constant, which is 6.02 exponent 23 particles per mole. The number of particles, these particles. Okay, and for B, the same applies, the same method, the same technique. Because you are asking for the number of particles, the same formula here. This one, that is N equals to N A. This is number of particles, number of moles, Avogadro is constant. So from there, you are given number of moles, that is 19. So you take there 19 times Avogadro is constant, that is 6.02 exponent 23. So this one will be equal to 1.14 exponent 25. Yes. Exponent 25 particles. Yes, so that is. Let's go for question number 5. Okay, this is question number 5. Calculate the volume of oxygen gas produced at standard temperature and pressure when 12.25 gram of potassium chloride is decomposed. Okay, for these problems of mole concept, you have to know the four main steps. Number 1 is to identify the required or asked term and the data given. For example, here, number 1, I have to consider, and I can underline, calculate the volume of oxygen. So it is required, that is the oxygen, and the data given is potassium chloride, this one. Okay. After identifying them, now you can write the balanced chemical equation. The balanced chemical equation, because this is a stoichiometric concept. So the balanced chemical equation here is because this potassium chloride is decomposed. So here we write that potassium chloride, okay? Potassium is balanced, the equation. Here, this is the gas. This can be a solid. So, how many oxygen? Here we can write 3. So here be 2, potassium 2, okay? So we found that 2 potassium, 2 chlorine, 2 chlorine, 6 oxygen, 6 oxygen. Now it is balanced. So this is a balanced chemical equation. So that is step number 2. And another step, okay, I said that you underline the asked and the asked one term and the given that. So volume of oxygen, underline this. So this is the one you are asked, and the data that you are given is potassium chlorate. That is this one. So you underline the important terms, the asked one and the given data one. But calculate the volume of oxygen. Now start comparing. You have the step number 3. Find the number of moles for the one that you are given that. Number of moles for each. So now go. This is potassium chlorate. Okay. So let's find the number of moles here. Number of moles for potassium chlorate will be given by mass over molar mass. So the number of moles here will be mass, which is 12.25 divided by the molar mass of potassium chlorate. Potassium chlorate. What is the molar mass of potassium chlorate? This is potassium chlorate here. Let's find potassium chlorate. Yes, this is 39 plus chlorine, that is 35.5 plus oxygen 48, that is 16.3. So this one here is 74.5, 74.5, then plus 48. You find it as the 1125. So 11.3. So then it is 112.5. Yes. So taking this mass over molar mass, how do you get this? This one will be equal to 0.1 mole. So now, for potassium chlorate, the number of moles is this one. But now you can compare, as I am required to find the volume of oxygen. Now, how about the number of moles for oxygen? If 2 moles of potassium chlorate used to produce 3 moles of oxygen. So, but here, number of moles of potassium chlorate is 0.1. So if this is 0.1 mole, how about this one? Number of moles of oxygen. So crossing multiplication there, you will find that x equals to this one divided by 2. 0.1 times 3 divided by 2. So dividing there, we'll get 0.3 divided by 2. Therefore, the number of moles of oxygen will be 0.15. Yes, 0.15 mole. Yes. So for oxygen, have 0.1 mole. Now let us proceed. If I have the number of moles, I can convert the number of moles into volume. Look, from the formula that number of moles is given by volume divided by gas molar volume. Gas molar volume. And this gas molar volume is always constant. That is always 22.4 decimeter cubic. At its standard temperature and pressure, gas molar volume is this, because we are given at standard temperature and pressure. Therefore, here I'm required to find the volume, but number of moles that you have already, this one. So I can do it 0 here, 0.15 equals to volume over this one, 22.4. Crossing multiplication there, you will find that volume equals to 0.15 times 22.4. And the volume of oxygen will be 3.36 liters or decimeter cubic. So now you can write your answer that the volume of oxygen produced will be equal to 3.36 decimeter cubic or 3.363 liters. Wow. The question number 6 is very interesting. Yes, question number 6. So I believe and I hope that you have got something. So in this question number 6, let us do it together, okay? Calcium hydroxide reacting with the ammonium chloride. Calculate the mass of ammonium chloride that will react completely with 14.8 grams of calcium hydroxide. From this question, first of all, write the balanced chemical equation that involve calcium hydroxide and the ammonium chloride. So here we go. Calcium hydroxide. This is calcium hydroxide reacting with ammonium chloride. Chemical formula for ammonium chloride, this one. What will be the product is? This is salt. However, it is acidic salt. So the product is will be calcium chloride aqueous. Of course, this is aqueous and this is aqueous. And another product that is after ammonium reacting with hydroxide, the product will be ammonia gas and water. Actually, another hydrogen there will form water. This is liquid. Let's try balance this question. Here we have chlorine, 2 chlorine. So here I write 2 chlorine, 2 nitrogen, 2 nitrogen. So let's see how many hydrogens we have there. Here 2 hydrogens, 8 hydrogens, 10 hydrogens. Here 6 hydrogen, 2. So this one becomes 10 now. How many oxygen? 2 oxygen. Yes. And here are 2. Now the equation is balanced. So after, let us underline the asked one and the given data one. Calcium hydroxide reacts with the ammonium chloride. Now, calculate the mass of ammonium chloride. The mass of ammonium chloride. Where is the ammonium chloride? This one. Underline the asked one. That will react completely with this calcium hydroxide. You are given this. Yeah, so these are the 2 things that you have to consider. Others you can leave them. So let us proceed. 1 mole. Well, the next step after this, find the number of moles for each. For example, here you have the calcium hydroxide, this one. So find the number of moles. So number of moles of calcium hydroxide is given by mass over molar mass. The mass you have, that is 14.8 gram, divided by the molar mass. Calcium hydroxide, so this is divided by 74 G per mole. Therefore, you can get certain number of moles. You can divide there. So here you get number of mole, that is a certain number. It will be 0.2 what mole. So after dividing this, you will get that number of mole is equal to 0.2 mole. Now let us compare that 1 mole of calcium hydroxide react with 2 mole of ammonium chloride. So here 1 mole of calcium hydroxide used to react with 2 moles of ammonium chloride. But if here you have 0.2 mole, how much will be here? If here is 1, here is 2. So if here is 0.2, so here will be 0.4 mole. Yes. So number of moles of ammonium chloride. For ammonium chloride, number of mole is equal to 0.4 mole. Now I am required to find the mass of ammonium chloride. From the formula, that number of mole is equal to mass over molar mass, but I am required to find mass. So cross multiplication there, you find mass is equal to number of moles times the molar mass. What is the molar mass for ammonium chloride? Let us do it in summary here. Ammonium chloride, this is equal to nitrogen is 14 plus hydrogen 4, 1 times 4. Chlorine is the 35.5. 18 plus this, so you will find that this is the 53.5. So mass is equal to number of mole 0.4 times 53.5. That is G per mole, and this one is mole for 0.4 mole. So taking this, you will find that the mass of ammonium chloride is 21.4 gram. Therefore, mass of ammonium chloride that will be used to react with that mass of calcium hydroxide is equal to 21.4 gram. Thank you. So you are welcome. I need your comment. You can ask more questions, and you can check me in DM for more questions and for more consultation. You are welcome. Thank you.